everyone, welcome to Research Express. Today we are going to discuss about smart charging station selection for EV vehicles using machine learning methods. In this smart charging station selection, in particular location, we have many EV charging stations. In that particular location, we can check via this app for which station is providing shortest path and how many times it will take to complete the charging hours. Like that, we can use this method to find the shortest and quickest charging station. By this, we have used Python, machine learning, XGBoost and Streamlit. In this project, we have used these many techniques. Now we are going to check the VS Code. This is the codes we have used. In this, we have the dataset, generated dataset. Then we have trained the model XGBoost. Then we have tested the station simulator. Then we have find out the distance and future importance, everything we have find out. The requirements we need to install. This is the text file we have used here. What are the requirement libraries we need to use here? Then amp.py is to run the output via this Streamlit. Now I am going to run the project. I am going to type Python Streamlit run app. Now I am going to run this code by clicking enter. Now that dashboard will open. It is running. This is the dashboard to find out intelligent EV charging station recommendation system or EV charging station selection by using XGBoost method. In this, here you can see this is the current location we need to select. I am going to select Tambaram. You can select whichever your current location. Next, you have the current SOC percentage. Your charger having the battery percentage. You can select this charging percentage. My charging percentage is now 33. Now I want to make it from 34 to 100. If my charging level is 27 means it will automatically change it to 28 to 100. My target battery percentage, if I am going to particular location, means I need this much amount of charger I need for the battery. I can choose the battery level. I need 90% means I need to select 90%. And then you know the battery capacity of your vehicle. It may be car or bike or any EV vehicle you have. In that, you have to select the battery capacity of your own vehicle. I am going to select 50. Now you have to select the recommend station. Now I am going to click the recommend station. In this, here you can see the recommended station will be Tambaram. Tambaram, nearby 1 kilometer distance it will be available. Waiting time is 0 minute because there is no vehicle in that place. I don't want to wait for charger. Next, these are the recommended details. 1 kilometer, available charger 3, charger is now available. Travel time 3 minutes around. Waiting time is 0 because 3 charger is available now. Charging time for this percentage to 90%, it will take 23 minutes. Charging completion time, total time, travel time plus charging time, total time. This is the total completion time. The XGBoost recommend this one Tambaram distance is 83% of out of 100. Now you can see what are the nearest location it is available. This is Tambaram is the 1 kilometer and you can see the traffic index with travel time. You can traffic index is very less when compared to last one and available charger is 3. You can check Porur. Distance is 14 kilometer. Traffic is very less and available charger 8. Queue length, I need to wait for 3 members. Travel time 35 minutes. Waiting time 9 minutes. Total charging time will be 31.5. Completed total time is around 1 hour above. These are the data will be provided from the distance and traffic time, available charger, queue length, how many charger, how many vehicles are in the queue. These are the details will be provided from this dashboard. Recommended score based on the data. So this is the which one is first. Tambaram is the first one. 83%, this is 75, this is OMR. Like that, they will provide the graph analysis. Next, based on the completion time, they have provided this details. Next, station health summary. You can check the station health summary from this. Congested area, excellent, moderate. Based on that, you can check the health level. Also, you can download the data via this download recommend report. Next, we can check any other details. I am from T Nagar means the same data I can choose and click the recommended station. T Nagar itself, I have the station. So, but it didn't select the T Nagar because that is 1 kilometer only. But they said best recommended station is Anna Nagar. T Nagar to Anna Nagar, there will be 9 kilometer waiting time. No need to wait because there will be no cars in queue or EV vehicles in queue. Distance is 9 kilometer. Available charger is 12. Travel time is 16. Waiting time is 0. These are the details they have mentioned. Now we can see top 5 recommended station. In this T Nagar, there will be more queue or more number of vehicles arrived. Available charger is not there because so that they didn't recommend the T Nagar EV charging station. Based on that, they will provide distance is 9 kilometer, but this distance is 6 kilometer. Gindi is 6 kilometer. This is 9 kilometer. Then you can check the traffic index. This is very less. Travel time is reduced by using traffic index. Next, waiting time is 0. Here Gindi waiting queue is 2 is already is there. Available charger here 4 only. During that time, they may be booked anything. Here available charger is 12. Based on that, the selection of recommended station will be provided by Anna Nagar. Now we can select any other one. I am going to select Adayar and click the recommended station. It shows Gindi 5 kilometer. Recommended station they have mentioned like this. Adayar Gindi, like that only they can provide. Here you can see Adayar to Adayar, there will be minimum distance only. It takes 1 kilometer, but Gindi have 5 kilometer distance. Why? Because they have selected available charger is 7, traffic index is less here, but the queue length is available here. EV cars or EV vehicles available in the queue is 12. But here only 1. Based on that, they have selected Gindi as the first one. Based on that, this dashboard will work for intelligent charging station recommendation system. Why we are choosing this EV charging recommendation system? We can see one by one. Electric vehicles are rapidly increasing worldwide. Major challenge faced by EV users: long waiting time, charger congestion, uncertain charger availability, increased charging completion time, difficulty in selecting the best charging station. This project develops an intelligent recommendation system that suggests the most suitable charging station using machine learning method. What is the problem statement we have taken here? Traditional navigation system recommended station primarily based on distance only, so that the nearest charging station may not always be the best choice due to long queue, limited charger availability, high traffic condition, longer charging completion time. We have discussed this one already. Next, the project objective is develop a smart charging station recommendation system or selection system. Predict user satisfaction using machine learning techniques. Multiple factors we can check simultaneously. Based on that, already we have visited the dashboard. Reduce waiting time and charging completion time. We can improve UV user experience. Provide a real-time station ranking. We can see the real-time station availability of chargers and distance and travel time, everything we can see from the dashboard. This is the system architecture. This what we need to do means we need to fill the current location and current SOC, target SOC. That means current percentage, battery percentage level, and we need to charge the total percentage. Then we need to fill the battery capacity. Next, we need to generate the details from the input, we can know the distance, travel time, waiting time, queue length, available charger, traffic index, charger power. Everything the dashboard will extract. Based on that XGBoost model, station ranking, and the output is best charging station recommendation. The output will be the best charging station recommendation from the model. This is the overall system architecture we have seen here. Next, dataset generation. The dataset contains 1 lakh records. The input features we have entered current location, station location, distance, traffic index, travel time, total charges, busy charges, available charges, queue length, waiting time, current SOC, target SOC, battery capacity, charger power. So the target is the satisfaction score out of 100. It will display. So that means this is the score out of 100. It shows 85.39. Like that, the output will be from the data set we can use here. Next, satisfaction score formulation. We have used travel time, waiting time, charging time, charger availability, queue length. Based on that satisfaction score, this is already we have checked. Next, distance matrix. Location we have considered Annanagar, Tinagar, Velacheri, Kambaram, OMR, Gindi, Nadayar, Poro, Coimbatore, Perungudi. We have estimated the travel distance time Tinagar to OMR, for example 15 km, Tinagar to Tinagar. That means the station to your current location around it takes 1 kilometer. This is the example we have used here. The same place means it takes 1 kilometer. Like that we have assumed and take. For real time we can use Google Map. That it will work real time manner. We can change this location based on your project work. You can change the location based on your area. Next, machine learning model. Why we can use XGBoost? Because this is produce high prediction accuracy, handles non-linear relationship, and fast training, future important analysis. We have used 14 features already. We can show what are the travel time, waiting time. These are the 14 parameters we have seen. The model output is predicted satisfaction score. Next, model performance. The metrics we have used MAE, RMSE, and R square. The R square score is 87.5%. The predicted versus actual satisfaction score is 87.5%. The model demonstrates strong predictive capability from the XGBoost method. This is the future importance analysis. We have used queue length, travel time, available charger, waiting time, distance, DC charges, traffic index, charger power, battery capacity, target. These are the top 10 future importance we have used. From this observation, we can indicate the user prefer station with shorter queues, even they are in long distance. This is the architecture we have seen already. Tinagar to OMR 15 kilometer distance, but the dashboard will say this is the recommended station because Tinagar to OMR 15 kilometers. The available charger is 19, queue length only 3, travel time is 5 because other station will have available charger is less and queue length is high. Based on that, it shows the best location is OMR from Tinagar. These are the other parameters. The conclusion and future work. The conclusion here is the developed intelligent EV charging recommendation system we have developed successfully predicted user satisfaction using XGBoost method. Considered multiple operational factors. We have used multiple operational factors. Based on that only the results by XGBoost method comes good. Improved charging station selection process we have achieved. Future work we can use a real-time GPS integration, live charger availability, Google Map API integration, deep learning models we can use when compared to XGBoost method. We can use mobile application deployment. These are the future work we can use. Thanks for watching our videos. Kindly subscribe our channel and also click the bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.